Now let us look into the write rotate program. The main purpose of this program is to develop a C function which has right shift of x comma n that takes two integers x and n as input variables and returns the value of the integer x rotated to the right by n bit positions. Also, this makes us understand about bitwise operators, unsigned integers and also the function return types. Now, the input for these programs are x, the value of x which is in 16 bits length and also the value of n. The output for this program is the right rotated value of x by n bits, and also we need to display the rotated value on the output screen. Before moving into the actual program, now let us discuss the logic behind this program. Before actually moving into the logic of this program, now let us understand some of the basic number system representation. For example, consider 4 decimal numbers like 0, 1, 2 and 3 whose binary representation are given as 0000, 01, 10 and 11, which are represented in 4-bit binary numbers. We can also consider here that 0 and 2 are the even numbers, 1 and 3 are the even numbers. This is in accordance with decimal numbers. But how to consider whether a given number is even or not when it is represented in binary digits? For that, we need to consider what is known as LSB, which stands for least significant bit. If we consider the least significant bit, whenever we have 0 in the least significant bit, we call those numbers as even. Consider here 0 and 2 are the even numbers. Similarly, correspondingly we have 0 and 0 as our LSB for the numbers 0 and 2. Hence, they are said to be even. In the same case, the numbers 1 and 3 are considered to be odd. Let's look into the binary representation. Since LSB consists of 1 and 1, we call them as odd numbers. Whenever we have LSB as 0, those numbers are said to be even. Whenever the LSB has 1, those numbers are said to be odd. Having this as our background, now let us move on to the actual program. Here consider the value of x as 21 and n as 1. That is, x is my given number which I want to rotate it by n times. That is, 21 has to be rotated by 1 time. Before actually moving into rotation, first let us understand the shift operation. To understand shift operation, let us consider the same x value 21 in decimal, which stands for 10101 when represented in binary. We can consider that 10101 is the binary representation of 21 and go back to LSB where 1 is existing, and we can clearly say that whenever an LSB has 1, we call it as odd number. 21 is an odd number. Now we want to shift 21 by 1 time. What happens when we shift 21 by 1 time? Say right shift 21 by 1 time. See, here we can carefully observe that double greater than is the operator which is used for shifting. Double greater than is for right shifting, double less than is for left shifting. Since we are considering for right shifting, we will use double greater than. 21 double greater than 1 indicates that we are trying to shift the value of 21 by 1 bit. Hence, what happens when we shift, the LSB moves out of the range, and the new vacant bit takes filled up by 0. Finally, the shifted bit will be 0, 1, 0, 1, 0. This is about shifting. Now, if we want to rotate a given number, consider the original number 21, 10101. Right rotation means I want to move the LSB of a given number to MSB of the same. That is, the last number 1 will be moved to the MSB position. Thus, the new number obtained after rotating the given number 21 by 1 bit is 11010. This is how the right shifting and right rotation works. Since in our C programming we do not have any operator support for rotation, we will mainly consider it on shifting and adding a deficit number, which is explained over here. Now, this was completely about the binary representation number on a whole. Now, we will move into the same numbers 8-bit representation. That is the number 21 along with its 8-bit representation, which is as follows. The x equals 21, which implies 00010101 will be its 8-bit representation as we count 1, 2, 3, 4, 5, 6, 7, 8. This is the 8-bit representation of the given number. Now, if I want to right rotate the same number 21 by 1 time, what happens here? See, this is our LSB. If the value of LSB is 1, then definitely the given number is odd. I need to rotate. Just move this position or the value of over here at the LSB to MSB. Then what happens? If this one moves to the MSB position, then the newly rotated number would be 1 followed by 1, 2, 3. 3 zeros followed by 1, 0, 1, 0, 1, 0, 1, 0. That's how we get this number right rotated, the value of x which is equal to 21 by 1 time. To understand this, since this is the logic of the right rotation which has to be implemented in C programming using shifting and addition, which is explained as follows. Consider the same number x equals 21 represented in 8 bits. The last LSB which stands for odd. And we can see that the conversion is 2 to the power of 0, 1, 2, 3, 4, 5, 6, 7, and their values are correspondingly 1, 2, 4, 8, 8 up to 128. We want to right shift by 1 bit. The given number 00010101 has to be right shifted by 1 bit. So that when we right shift this number by 1 bit, this number goes out and 1010 will be the left out number with 3 zeros before that, and the new vacant bit will be filled up with always by 0. Thus, this is the number obtained after shifting by 1 bit. But we have not completed the right rotation. To complete the right rotation, we need to add the value of MSB. That is, since we have 8 bits, we have to add the value of 2 to the power of 7. The 2 to the power of 7 value is 128. If we have 4 bit, we need to add 2 to the power of 3, that is 8. Since we are having 8 bits, we need to add 2 to the power of 7, that is 128. Once when we add the value 128 to this, we will get the new number obtained would be 1 followed by 001010. This is the number obtained after right rotation. And when we compare these two numbers, this was the number obtained logically. This is the number obtained programmatically. And we can clearly see that both the numbers are one and the same. This is all about 8-bit representation of a number 21, which is right rotated by one time. But in our program, we need to consider the 16-bit representation, which is clearly explained as follows. Now, we will consider the 16-bit representation of the given number x. Here, the given number x is 21, which when represented in 16-bit appears like 11 zeros followed by 10101. If I want to rotate the given number x by 1 bit, then this LSB position 1 comes to the MSB, and newly rotated bit would be 1 followed by 11 zeros 1010. This is how the mathematical representation of the right rotation occurs. Now we will consider the same programmatically. Here we have the number x equals 21, which is represented using 11 zeros followed by 10101, which is 16-bit representation of a given number. Now, similar to the 8-bit representation, we need to right shift the given number by 1 bit. After right shifting, this 1 which is at the LSB goes out, and newly vacant bit will be always filled up with 0. Next, what happens? We need to add the value of the MSB. Here, the value of MSB is 2 to the power of 15, which is equal to 32768. As we can see that this is 1, 2, 4, 8, etc., 64, 512, 2048, and this 2 to the power of 15 is nothing but 32768. After adding the value 32768 to the right shifted bit, we will get the final answer as 1 followed by 11 zeros 1010. Now we can clearly observe that the programmatically found out number is always equal to the theoretical value of the rotated number. Why we actually do like this is that we know that this is right rotating, and since we do not have any right rotate operator which is available in C programming language, we make use of shifting and adding. This concludes the logic of this program. Let us look into the actual program to rotate right. The first line here is hash include stdio.h, which is the preprocessor directive along with standard input output header file, and the next two lines are the header files. They are conio.h as well as math.h, which includes conio stands for console input output and math stands for mathematical header file. Now we have the function to right rotate. Before actually moving into the function, we shall look into the main function from which our execution starts. Here we have void main function, and the very first line is called as a declaration. Here in declaration we have the variables x, y, n, I and value, which all have been declared with an unsigned int data type. An unsigned int data type consists of no signs. Hence, this is also an integer data type without any signs. The signs are always given in MSB of a given bit. Since there are no signs, here it is called as unsigned integer data type. Next, what we have is an input variable which is declared in character for an option which will be clearly seen in our output. Next line we have is the clear screen, which is used to clear the output screen. Next we have is the do while block. Inside the do, which has enter the number and number of bits to be rotated. Here we need to insert the value of x as well as n. Here x stands for the actual number which we want to rotate and n stands for total number of times we have to rotate. And carefully observe here that in scanf statement we have a new format specifier %u which stands for unsigned integers. Next we will assign the value of x to y and a right shift of x comma n a function will be called. The value of x is assigned to one more variable y and the function right shift of x comma n will be called. The answer of that function will be stored in a variable known as value. As soon as the right shift of x comma n function is being called, the control moves to unsigned int right shift of x comma n value. Here also we can note that the parameters x and n are being declared as unsigned integers. Inside this function we have a variable I which is of integer data type, and next we have is a for loop. Here for loop runs from 0 to n. Carefully note that n is the total number of times we want to rotate the given number x. That will be placed inside our for loop. The next condition is if x mod 2 is equal to 0. This is a condition which we use to check whether the given number is even or odd. If the value returned here is 0, then the LSB would be 0 and the given number would be even. If this is the case, we need to just right shift by 1 bit position. Suppose if the given number is odd, then the else part will be executed where it involves right shifting by 1 and adding the value 2 to the power of 15. 2 to the power of 15 is the MSB value of a 16-bit length binary number. The 2 to the power of 15 value is 32768. Hence, x is added with 32768. Thus, this returns the value of x when it has been completed by n bit rotation. After rotating the number x by n bits, the control moves back to the main function. In the main function, here we can see that the calculated value right rot of %u comma %u equals %u. That is, the given number has been rotated by so many bits and the value is given by once again the %u. This we can see in our output. And we also have, if we want to continue executing in the output screen, we can either press Y. If we want to stop the execution, we need to press N. That's what is given in input equals get character. While input of I not equal to N, meaning that whenever a user has pressed N, this comes out of execution. The program is ready for compiling and execution. The key what we are pressing for compiling is Alt F9. As we can see that there are no warnings or no errors, we can directly execute the program. To run or execute, we need to press Ctrl F9. Here it asks us to enter the number and total number of bits to be rotated. Suppose if I give the same number 21 and asks it to rotate by 1 bit position, here we can clearly see that the calculated value right rot of 21, 1 equals 32778, which when represented using binary we will get the value as 1 followed by 11 zeros and 1010. Now again it is asking us whether to continue we have to press Y or else we need to press N. We will take one more output. Now enter the number and number of bits to be rotated. Suppose I enter the number as 8 and want to rotate by 1. As I know that whenever we have a even number 8 rotated by 1 bit, it exactly divides by 2 and the output should be always 4. As we can clearly see that the calculated value right rot of 8 comma 1 equals 4. Now I want to come out of the output screen and stop the execution. Hence, I press the character N. This completes the right rotation program.